Now this video is entitled Two Forces, and I'm going to talk about this for a second. Now, gravity always pulls you down to the earth, okay? If we weren't being pulled down by gravity, I'd float out of this chair and you wouldn't see me, type thing, okay? This board would go someplace, the camera would go someplace else, so on and so forth. So gravity pulls me directly to the ground, okay? Now, let's say you have a truck. Regardless of whether it goes uphill or it goes downhill, gravity works on this truck in two directions. Number one, if this is a hill, this truck is going to stay on that hill. Why? Because gravity is forcing the truck to stay on this hill. Alright? That's one force. The other force is the gravity trying to drag the truck down to the ground. Okay? Now, you may want that kind of situation, you may not. If you're trying to go uphill, you don't want gravity dragging you to the ground. But if you're going downhill, you definitely want gravity dragging you to the ground because that's where you're headed anyway. Okay? So, you have to calculate how much force is involved between the gravity dragging you to the hill itself, keeping you on the hill instead of floating away, and the gravity that is trying to drag you to the ground. Okay? Basically, it's the gravity trying to drag you to the bottom of the hill. So how do you calculate all this? With geometric vectors. Okay? And the line you draw to those geometric vectors is going to be the force between the gravity keeping you on the ground and the gravity trying to drag you to the bottom of the hill. And that's how the two forces actually work. I will tell you more in the next video, so stay tuned.